In the previous tutorial, we began to learn about cladistics, so we are now familiar with the clade as the fundamental unit of phylogeny. But we have also learned about taxa when discussing the tree of life, which seem to imply the same concept. So what's the difference between these two terms? There is indeed an important distinction between the terms clade and taxon. A clade is a group of organisms that share a common ancestor, like the family Felidae in the cladogram we are familiar with. Taxa, meanwhile, do not always indicate common ancestry. In order to explain the difference, we need to introduce the terms monophyly, paraphyly, and polyphyly. These will make more sense with a diagram for context, so let's introduce another cladogram. First, take a moment to just review the diagram and use your knowledge of how cladograms work to determine which groups are more closely related and which are more distantly related. In this cladogram, the amphibians are the outgroup, and the ancestral characteristic is amniotic eggs. The embryos of mammals, crocodiles, lizards, and birds all develop in amniotic sacs, filled with fluid which keeps the embryo moist. Now, if we were to group the crocodiles and the birds together, we would get a monophyletic taxon, also known as a clade. The crocodiles and the birds are the two most closely related organisms in this cladogram. By grouping them together, we are including all extant organisms that fit these categories and their descendants, as well as all of their ancestors going back to and including the most recent common ancestor of the two branches. Now, if we group together the lizards and the crocodiles, we create a paraphyletic grouping. This is because we are not including all their descendants, as birds are clearly omitted, and this is the key difference between monophyly and paraphyly. So the classification of reptile is actually paraphyletic, but the classification archosaur is monophyletic, because the latter encapsulates all descendants. If we were then to try and group the mammals and the birds together as being warm-blooded, we are now creating a polyphyletic grouping, because the mammals and birds do not share recent common ancestry. Let's now display these groupings all at once, monophyly, paraphyly, and polyphyly, so that we can more clearly see the differences between them. As we can now understand, the term monophyletic taxon is synonymous with the term clade. They mean the same thing, a group of organisms that represent all of the descendants of their most recent common ancestor. Monophyletic groups, or clades, are therefore a part of both evolutionary and cladistic taxonomy. A major goal of taxonomists is to determine which groups are monophyletic, paraphyletic, or polyphyletic. Since the term reptile is paraphyletic, it is rejected by some taxonomists, unless it also includes birds. Other taxonomists accept the grouping, but simply recognize that it is not monophyletic. Polyphyletic groups, on the other hand, are almost always rejected. The taxon Vermes, for example, used to include all known species of worms. However, this taxon is polyphyletic because many species of worms do not share recent common ancestry. A more detailed way of indicating common ancestry is through the use of phylogenetic trees. Though they are similar to cladograms, phylogenetic trees represent real evolutionary lineages, while cladograms are merely formal devices for indicating the hierarchy of clades. Like cladograms, animals that are grouped close together with shorter lines, like lampreys and jawed fishes, are more closely related to each other than to animals that are further away, like the echinoderms. Since the echinoderms are so far away from the jawed fishes, it may seem tempting to refer to them as primitive animals, and the jawed vertebrates as complex animals. However, these terms are misleading. A starfish is no more primitive than a human. Starfish do, of course, lack many human characteristics, but likewise, humans lack many starfish characteristics. It is more accurate to call organisms that branched from the evolutionary tree long ago as basal animals, since they are so distantly related to many other extant groups. A sponge, for example, may seem primitive, but they have been evolving for just as long as any other extant animal species. They simply diverged earlier. Before we wrap up with cladistics, it's important to remember that cladograms and even phylogenetic trees are simply ideas. They are useful guides that help us to understand the relationships between animals, but they are not set in stone. They can be rewritten when new discoveries are made. If we were to envision a massive cladogram representative of the entire animal kingdom, this would undoubtedly be edited continually as we learn more about known species and discover new ones. Speaking of such a monstrosity, we are now ready to explore Kingdom Animalia as a whole, so let's move forward and do just that.